Okay, so let's just look at the next question. And this is a question involving a utility function. And we have two variables, x1 and x2. So an individual's utility function is given by that big function there. We'll worry about that now in a minute. Let's just ignore it for a minute. We'll not start reading it, concentrating too much on it. So x1 is the amount of leisure measured in hours per week. So really x1 is just the number of hours of free time the individual has, and x2 is the income measured in euro per week. So what do they want first? Find the marginal utilities del u del x1 and del u del x2. So that means differentiate u with respect to x1 first, and then differentiate u with respect to x2. And he wants to know what are the values of those partial derivatives when x1 is that number there, 112, and when x2 is the other number, that 663. Right, so it's clear what I have to do. I have to partial differentiate u with respect to x1 first, and then with respect to x2 later. Right, so what I'm going to do, I'm just going to go down to a new white space in the whiteboard. I'm just going to take that function with me. So what do I have? I have part A, and I'll just paste that down now to the area down here. So I need to differentiate that with respect to x1. Now, I can just hop right to it. I can use my boxes as I did with the previous two questions. If I need to do it with respect to x1 first, put any numbers in x2s in the boxes. There's just one thing though here that might annoy people, that you see x1 squared, that, a term like that, x1 squared, it's kind of, it can be hard to even look at that, because you could, by mistake, you could think you need to do something with that x1, that 1 on the x1. The x1 is just the name, or a variable. So you treat the whole thing as x1. So when I differentiate that term in the circle with respect to x1, I take that power down, I would have minus 4x1. But I understand that some people may say, oh, I don't, they may by mistake, and do I take a 1 off there as well, by accident. So what you could do here is make life easier. You're allowed to rename variables in a question, now as long as you do it right. But you are allowed to rename variables, maybe to make an equation look a bit better looking. What if I just call the x1 x's, and maybe call the x2's y? Okay, so I'm going to literally say that. Call x1, call that x. Okay, call x1 x, and call x2 y. Okay. Now, let's rewrite the equation. So we'll have u x y, equals 120x1, but I'm calling that x, plus 50x2, but I'm calling that y. Again, so I'm going to just replace the x1 and the y, the x1 and the y, sorry, the x1 and the x2 by x and y. It might make life a bit easier, and you don't have to worry about them numbers 1 and 2 down in the bottom. So that'll be 2x squared minus 4y squared. Now again, just be careful that you have this done right, because you're allowed to do this, but if you do it, it's not, it'll make life easier, but just double check that you actually have it done correctly. So they wanted the partial derivative with respect to x1. So now, because I renamed everything, del u del x1 is just the same thing now as del u del x in this equation here. Okay, so again, I'm going to throw everything into, I need that there first. So if you want to throw everything into boxes, so I know that u equals, so everything just in terms of x now. Okay, so if it's not x, throw it in the box. 50y minus 10 y in the box there. I'll keep that minus outside, it's okay. And then I have minus, there's I'll put it like this, 2x squared. If you want to write plus 2, plus minus 2 in there as well, that would work as well, but whatever you want. And then minus and 4y squared, there's no x there, so throw the entire 4y squared into the box and there's no x. Okay, just put that 2 over there. Now, let's rewrite, just to make life easier, let's write a sort of a fake equation. So maybe 3, just anything, you do anything. The boxes all become numbers. So put in any old number at all. Minus 2x minus 7x squared minus 9. Okay? And think, how would you differentiate that and then differentiate u in the exact same way? So I'll have, let's just go down a little bit. So what'll I have? I'll have del u del x equals, so I would just have the box left, the same way I would just have the tree left there, so I just have the box left on its own, what goes in there, 120, plus, now, if I differentiate a number on its own, it disappears, so it's the same idea with the box on its own here, it'll have to disappear, so I'm just left with nothing, so I'm actually just going to skip right over it, or maybe just put a 0 there then. Again, so what would it survive here? We just have minus box, and the 10y goes in there. For that term there, I would take the 2 down and I would take 1 off it, so treat the box in the same way. I would have minus 2 box x and up to the power of 1, and I won't even bother writing the power of 1. And again, the same with the plus 11 here, the minus 9, the whole thing just goes to 0, plus or minus, whatever way you want to write it, minus 0. It doesn't matter if I write plus or minus 0, it's going to disappear anyway. So what am I left with? I have 120 minus 10y minus 4x. Fine. Now, the next thing I need is del u del y, okay? So, technically I was asked for del u del x2, wasn't I? But I decided to rename all the x2s. I just decided, to make life easier for myself, I just said rename them y, del u del y. Now you do not have to do this. It's just to make, if you're comfortable enough differentiating the x1s and the x2s, then go ahead, do that, that's no problem. But this just makes life a little bit easier. You get no more extra marks either way, it doesn't matter what way you do it. So I haven't that much space, I'm just going to retake this down again. I need to take it a bit more down. Okay, whoops. So I have, just going to get rid of these little extra bits. Okay, so now again, as before, I just need the function in terms of y now. So anything that's not y into a box, or bin it. U equals, the whole thing goes into the bin there, 120x, plus what goes in the bin there, the 50, and the y stays out, minus 10x, y stays out, minus all of that can go into the bin. There's no y there, I don't need to know about it. And for that there I have minus, I'll put the 4 in there, and the y squared stays out. Okay, again, just quickly write down any dummy equation and replace the box by numbers. 2y, anything at all, 9y minus 7 minus 3y squared. Okay. So just double check how you would differentiate that in the grey and do the exact same thing with the u, but treat the boxes as just them numbers. So differentiate a number or a box on its own, just left with 0, plus 50, plus the box on its own here, minus just the box on its own again, 10x, because if we were differentiating minus y, minus 9y, I would just say minus 9 is left over. So minus box y, minus box is left over. Minus 7 would go to 0, so again the minus box would go to the 0, so I just have minus 0 there, and what do I have? Take the 2 down in front of the box and take 1 off the power of y. I'm left with 1, don't bother writing it. Little clean up, 50 minus 10x minus 8y. Now, that's the partial derivatives found, but what they asked was you have to find the partial derivatives, or the marginal utilities is their technical name in this question, when x1 equals 112 and when x2 equals 663. Right, again, I'm just going to copy them down again for myself. So I need to find the values of them partial derivatives when x1 equals 112 and when x2 equals 663. So again, if you're happy and you stayed with x1 and x2, then I'm going to sub them into the partial derivatives. But remember, if you changed it, then you called x1, you just called it x. And x2, I called it y, so y equals 663. Okay, so the first partial derivative I'm going to sub into is the del u del x, or the del u del x1, whatever way you want to do it. Hopefully I'm not confusing you too much by interchanging the letters, but I think again that, if you have trouble with that x, them subscripts 1 and 2 in the bottom, then it might be a little bit easier to do it that way. So I need to sub in 112 for x and 663 for y. So do you know what I'm going to do? I'm going to use these pink memory buttons on the calculator. See the capital letters A, B, C, D, E, F, X, Y, and M. I can store numbers into those letters and write an equation into the calculator using those letters. It's kind of like what I was doing with the answer button in the calculator video. If you want to check that out, this is another way. The answer button is great when you want to sub one number into an expression, but I wanted to sub two numbers into an expression here, and these were in a case like that, these memory buttons come in very handy. So what I'm going to do, I need to, what was it for x? The x value was 112. So what I'm going to do, I'm going to go write 112 and I'm going to store it into x. Now, why am I saying store? Because it's, if you see that yellow, above the RCL button in yellow, it says STO, and that stands for store. And what I'm going to do is press shift to activate that button and then choose the letter I want to store 112 into, and it's that x. So what that then the calculator shows 112 is stored into x. Okay, so do the same now for the y, 663, and store it into y. Now we can write this expression in here in the calculator, 120 minus 10. Now to get into that x button, I need to press the alpha button. Whoops, that should be y. Minus 4 times x. And I get minus 6958. So that's the value of the marginal utility del u del x1, or del u del x, what I called it. So I'll write that down now. I have my del u del x. Well, let's just say, because he asked for del u del x1, so del u del x1 is what I called del u del x, and the value of that is minus 6958. Minus 6958. Now I just repeat now for the y derivative, del u del x2, that's what I called the y derivative. Now I have a little problem. I meant to call that earlier. I should have called that del u del y. That was the y derivative of u. So the same idea, use the x and y buttons on the calculator. 50 minus 10 x minus 8, again make sure you press the shift button, or the alpha button, sorry, y, and I get minus 6374. Okay, so let's take that down onto our answer. Del u del x2, that's what I called that was del u del y, and we just found out that's minus 6374. Now, what I'm doing in the calculator there, it looks like it nearly looks complicated the way I explain it and how long it takes me to explain it. But once you get the hang of it, you're not going to talk through it yourself. You're just going to fire it all in, and it can make some of these answers. It can quicken you up when you're answering some of these questions. Hopefully, it didn't confuse you renaming the variables, but it might make life easier for some people. Okay. Okay, so let's just look at the next part of the question. The individual is required to work for 4 additional hours per week. I'm at part B here. approximate the change required in income to maintain the same value of u. Okay, so let's just take that question down. So what they want us to use here is the small increment formula. Now change, so it's the small increment formula. Increment formula. Now, if you check your notes, you'll see it written like this. The change in u equals the first partial derivative, that del u del x1, by the change in x1, plus the second partial derivative, del u del x2, by the change in x2. Now, if you rename the variables x1 and x2, if you rename them to x and y, then you can just rewrite that yourself. Then that would be del u del x by the change in x plus del u del y by the change in y. Again, you don't have to rename them. It just might make life a little bit easier when you're looking at x1 and x2. Okay, so what has happened? The individual is required to work for 4 additional hours per week. Now, remember that x1 or x, if you renamed it, is the amount of free time, the amount of leisure hours they have, that this person has, and x2 is the income. So or x is the leisure hours and y is the income. Okay, so what they're saying down here is that he's now required to work 4 additional hours per week. So that means the x1, or just the x, has changed. He's x1 or x is the leisure hours. He's lost 4 leisure hours. So that means the change, and I'm just going to call it now x, the change in x is not plus 4, it's minus 4, because it was free time. He's lost 4 hours free time. Because that's what they called x, or x1, the leisure hours, the free time. So an additional 4 hours means you lost 4 hours free time. And approximate the change required in income to maintain the same value of u. So they're saying here, they don't want u to change, so there's no change in u. So what that means, that change in u must be just equal to 0. Okay, so what we're going to do, we're going to sub everything we know into the formula. Now, so and you might say, so we don't know these. Do we know these? We do. You evaluated them in the last question. There they are there. Del u del x and del u del y, and they are them numbers there. So let's sub everything into the formula that we know. We had, if I take, so remember, I'm just taking all of this down here. So I can call that triangle u, or I'll call it delta u. It means the change in u. So as we said, that's, I'm going to call that 0 equals the first partial derivative. The number was minus 6958. Okay, so minus 6958 by the change in x, which is minus 4. Okay, plus del u del y, what was that? That was minus 6374. Minus 6374, and I have not been given the change in income, because that's what I was asked. Approximate the required change in income, or the change required in income. So I don't know del y, the change in income, so I just leave it as del y, or as I said, if you didn't rename the variables, it would be delta x2. So, but I have delta y here. Okay, so I'm looking for delta y, so get everybody to the other side, get the delta y to one side and everybody to the other side. So you can do this a couple of ways. What I might do is, because everybody likes to write the letters here, you know, the x or whatever I'm looking for equals numbers. So I'll do it like that there then, and I'll take this term here over to the other side. So I'm going to have to change it to a minus. Now there's a minus there already, so what I'll do, I'll just keep it as it looks, keep everything in the brackets and say, well, I must change it to a minus whatever was there before. Okay, so I'll have minus 6, that was there before on the other side, so I'm keeping everything as it was and putting that minus there as why because I'm taking it the other side, and equals, that stays on that side, minus 6958, whoops, by minus 4. Okay, now if you're stuck, you can change that minus by a minus as a plus. But what I'm going to do, I'm going to let the calculator worry about all that there. I'm not going to worry about it. And remember, if you had to solve this, 5x equals 7. How do you solve that? It's x equals 7 over 5, okay? So treat this big, I know it's a much uglier equation, but treat it the same way. This is the 5, that's the 7, so take the 5 down and underneath. So I'll have delta y, and type everything then in the calculator. Delta y 6958 by minus 4, and on the bottom line I'll have the minus 6374, and that's it. Okay, so type what you see. Now you don't have to keep all in brackets there. You could multiply stuff out in the meantime, but if you're not confident in that change signs and change the pluses to minuses, then just keep it like that and type what you see in the calculator. Just press the fraction button and type what you see. Minus 6958 by minus 4, and then go down and change that to a minus. Just type what you see. Don't do anything in your head if you're not confident in it. And I get 4. I'll take it as 4.36 or 4.4, whatever you want. It doesn't really matter. 4.4. So that means the change in income needs to be, and even though we don't write it, there's a plus 4.4 there. So that means the income needs to increase because there's a plus there. If it was minus, it would be decrease. But the that means income needs to increase by 4.4 units. Okay. The next part, I'll put a square around it again. I have estimate the change in U if the individual has his working week reduced by 2 hours and his income increased by 20 units. Okay, let's just take that down again. I'll have to copy it, 2 seconds. Okay, so I have part C. Estimate the change in U if working week goes up by 2 hours and income decreases by 20 units. Or, well, 20 euro, I suppose, in this case. So again, I'm going to use a small increment formula. So I have, what was it again? I'll just take it down what I had before. I had this here. The change in U equals the partial derivative, first partial derivative by the change in x, plus the second partial derivative by the change in y. Now, what was I given this time? Now, remember, these partial derivatives, you've already worked them out because they're the numbers up above. So estimate the change in y. What have I been given? I don't know the change in y because that's what I'm asked to find, but I do know the change in x, which was the change in the working hours, were really the change in the free time, and x2 was the change in income. Okay, so again, my partial derivatives are what they are. Let's go up and take them. We had the first partial derivative was minus 6958. Minus 6958. Now remember, x1 is the number of hours of free time. So he has been asked, his working week has been reduced by 2 hours. That means he gained 2 hours in free time. So my change in the first variable, my change in x1 or my change in x, whatever I renamed them as, is plus 2 because I gained 2 hours free time. The second partial derivative was what? Minus 6374. minus 6374, and the change in x2, or as I called it earlier, y, that was the income, I gained 20 units. That's going to be plus 20. Now go straight over to the calculator, don't work it out in bits and pieces, just type exactly what you see in the calculator, okay? So minus 6958, if you want, it doesn't matter, plus 2 or just 2, plus minus 6374 by the plus 20 there. Okay, and what do I have? Minus 141396. Minus 141, what was it? Minus 141396. Okay, so that means you, be careful now, it's a decrease here. So that means, because that minus there, that implies u decreases by 141396 units. Okay,